All right, in this video I want to highlight a different feature of the graphing calculator, and the feature is the fact that you can load whole documents onto your calculator and then access those documents. You can load these documents on your students' calculators and let them have access to them. And a document isn't like a Word document, it's more like an interactive document. So I've got one here, it's under my current, so under my document menu, it's the current one I have, so I'm just going to click that. And so my document, and again, an interactive document, is called slope as rate. And I've got a few directions on here, and you can see above the 1.1, the 1.2, the 2.1. These are different pages within that document. So I've got that, but then also supporting this is a Word document. And all of these things I should mention are on a TI website. They have a whole library of documents like that. So any teacher, if you're looking for an activity, say I need a hands-on activity to get at slope, or to get at some of the measure of the angles of a triangle, you can go search their site. You might find the exact document you're looking for, or you might find one kind of what you're looking for. If it's kind of what you're looking for, these are very easy to edit any of these documents and kind of fine-tune it for your classroom. So here's the Word document that goes with the calculator document. This gives a little more detailed in terms of the instructions, and also it gives the gives the student a place to record their answers. And you'll see some of the questions. We'll come back to the questions in a minute and some of the really good questions that are asked on here. But back to the calculator. So the students have these documents, and 1.1 is just an introduction. I'm going to right arrow. And here's page 1.2, and here's the interactive part of the document. We can see a line here. We can see points on the line. Up above, we can see they've calculated the vertical change over the horizontal change. This is a huge idea in algebra. This is slope. And so this slope on this one we can see is 0.6. Well, the nice part about the interactive documents is I can click on this, or the students can click on this, and start to move this point around. As this point moves around, you can see the slope changes. So you can start to explore this a little bit. How about here? What kind of a line is that? Well, if I read left to right, that looks like a steep line. Look at that slope. It's 4.5. So that slope gives you an indication of the steepness. Move this up here. Oh, look, this is not very steep at all. 0.067 is the slope. Can you get a zero slope? Sure can. When do you get a zero slope? When the y-coordinates are the same. So all these questions that you could ask, or facts that you could have told the kids, they can start to explore on their own. Can you get a negative slope? Sure. We read left to right. So why don't we put the line that way? Look at that. It's a negative slope. Can you ever get a slope that doesn't make any sense? Let's just keep bringing this over here. Oh, look at that. The slope is undefined. Why would it be undefined? Well, look, the horizontal change. I've got 5 for my x-coordinate, 5 for my other x-coordinate. 5 minus 5 is 0. You can't have a 0 in the bottom of a fraction. So all these things, as the students are playing with this and manipulating these and really kind of enjoying doing math, you can be asking these questions as they go along through it. Additionally, we had these worksheets. I'll just highlight a little bit of this. I won't take you through the whole worksheet, but you'll look at some of the questions that are asked here. So first of all, question 1, they're recording their values. They wanted a slope of 0.6, so different x and y coordinates for that. But number 2, so look at 2b. You have to answer the question, but at the very end of 2b, it says explain your reasoning. So not only is it important to get the right answer, but part of the Common Core standards that we're dealing with now is students need to explain themselves. And with these activities and these hands-on discovery things, students are in a much better position to explain what has happened because they saw it and they manipulated it or they controlled it. So they can explain their reasoning better. Or down here, number 3, look at that. What's the question? Why does this make sense? So not only are they getting the correct answer, but they can explain their answers, which is really what we're looking for now in math, not just that analytical understanding where you can put things in a formula and get an answer, but you really understand what's going on. In this case, do you really understand what's going on with the slope? And I would argue with something like this, kids have a much better understanding of slope. Why is that negative? Why is this 0? Why is this positive? They can see these things changing right before them. And just to show you a little bit more of this document, here's a second kind of chapter to our document. And over here, very similar, we've got a line. If we move this point on the line, we look at this. The slope doesn't change anywhere on this line. That's an important concept for kids to know. So a line has the same slope everywhere. Or if we click over here, we can move the line, and again, you see that slope changing. When is it positive? When is it negative? The horizontal change is held constant this time, and you can see the vertical change getting smaller. There it's a negative vertical change. There it's a positive vertical change. Oh, look, we're making that vertical change huge. Wow, get up to the 60s that time if you want. But again, by moving these around and letting each kid kind of go at their own pace with this, individualizing it, every kid can make, hopefully, common discoveries, but they can also make their own individual discoveries as well. So it gives them a little more ownership in it, and it lets them, like I said before, it lets them explain what they're doing and give reasons for what they're doing, and much more in line with what the Common Core is asking our students to do.